After you've gotten your scripts and your functions all figured out and you've tested it, then it's time to set up the triggers. And you can see this in the dashboard from where your projects are. You can click into the My Trigger section inside the G Suite Developer Hub. And you can see here, these are actually the function names that you might have seen before from when I was walking through the scripts. And they're set on these times to run. And so, for example, these two here, which is the main function that runs every night to email me if I forget to plug one of the cars in. And so you can see here it's very simple drop-down menu. You can tell it when to notify you if something goes wrong. And you pick the function out of those scripts you have. You tell it whether it's on a certain date you want to run it or on a daily basis, monthly, whatever specific time. It's very flexible. I have it run at 10 o'clock because that's usually the latest I'll generally be home and before I have to charge my time of use starting at 11 p.m. So I'll run it at this time, and this is the same for the other car. And then the later on in the day, I take a snapshot around midnight to capture the full day's sort of energy usage, the telemetry around the battery, and you can see here it's very similar. I run it every day. I run it from midnight to 1 a.m. And they run within a 20-minute block. They're not like dead on. You can see here from the times, in fact, even though I picked midnight to 1 a.m., it runs 12:19, 12:42, so it's not super precise, although the ones where you set to run at a specific time, those are pretty accurate. And so those are the two that I run to write the data every evening to snap a full day's picture of all the telemetry. This truncate log, this is the one I run on a weekly basis to trim the error log to no more than 30 days. So this one, you can see it runs every Sunday versus every day. And then these two, these are the ones actually created by the scripts themselves. So based on the calculations from the Google Sheet, it calculates the optimum time to start these to finish at 6 a.m. So you can see here how it's very precise. It gives you 318, and I showed you from our previous video that was actually the value in the spreadsheet, 318. So it puts in the right date and everything like that. And they're one-time use, so you can see here, as I mentioned earlier, once they run once, because they're for a specific date and time, they're disabled after that. And if I refresh this page, they'll actually disappear. They just, they self-remove, which is actually quite nice. So until this runs again tonight, when it runs, it'll create new functions for those to set and to run at those particular times. So that's the trigger setup here and the dashboard, and you can go into the executions as well to see how long each one ran, if anyone ran into the problems. So that's a pretty nice user interface for developers to set up these triggers. As I mentioned previously, there's another kind of fun spreadsheet I created using the odometer information and some of the other, you can actually use some of the information from the API as well. But this calculates how much money I'm saving on gas with these two vehicles. And so if you look at this, how I'm calculating it, this will actually get the data every day. I used to have to manually punch these in, but even within Google Sheets, you can make a API call to the other sheet and pull in that data real time from the other one where it was written every day, every evening from the API calls. So this will be very accurate, to the day. These I just pulled out of the, looking in the car, but I could also replace these with the calculations that are done in the other spreadsheets. And then basically from the two, I can do the math and figure out how much estimated total kilowatt hours I've used in the vehicles. These rates are from, PG&E, from an average of the different seasons they have. And then from total kilowatt hours, I can just do the straight math, and then it'll tell you how much it is. So to charge both vehicles, to date, actually hasn't been very much at all. So, for our mileage, which decently high mileage, it's about $1,500. So that's not bad for charging, and obviously this will depend on your usage and electrical rates in your state or city. And then I compared it to, an internal combustion engine, and this is compared to vehicles we had before. So wife had an SUV, so that got a very low mileage. I had you know, a regular car. It wasn't a hybrid or anything like that, so the mileage was, so-so. And excuse me, the gas price obviously varies, but I think in my area it's roughly around, a little average, probably a little bit of above $4. And you can see here that it's a very substantial difference in total cost if we had driven the same number of miles, paying for gas. And so that's quite a big difference. So each year you're saving roughly $7,000. Excuse me, roughly $6,000 you're saving between my two vehicles in gas, in gas. And then if you look here, I created a chart here, and when you look at sort of how this plays out, right? So through a 10-year period, and you may not keep your car for 10 years, but you can see that you'll see soon that this is attractive even if you keep the car for, 3 or 4 years. But you see the gas savings cumulative over time is quite substantial. And then I also have down here savings for the ICE vehicle, the internal combustion vehicle, which is you're saving things like how often you have to change brakes, um, you know, different inspections. This is actually based on the previous car I had, which is a BMW. So the service schedule, the maintenance you had to do for the car, the oil changes. So those are things that you would not have to do. Obviously, you still have to do tires and whatnot. So I added those in. So these are things like, changing the tires out, the wipers. So the net difference there, you can see here within. And I also, these aren't just tires. So actually, I actually spent a fair amount of money because my home is a little bit older. I had to spend quite a bit of money on upgrading my electrical panel, and I had to install a bunch of other new stuff, which actually is in a different video about charging two electric vehicles. So I had to get some special equipment installed, and it actually was quite a substantial amount of money I spent on it. You can see it's here, it's roughly like $12,000. And that includes high-powered wall connectors. And so, but you can see here with the savings within even just, one year, by the second year, it's already sort of paid itself back by saving just on the gas and not spending it on, oil changes or whatnot. And you can see how quickly the savings stack up. Like I said, within 3, 4, 5, years and on until 10 years, which is actually a pretty reasonable amount of time to keep cars. And that's a substantial amount of savings from just, and most of it's from gasoline savings, right? And if you use solar, I imagine it will be even better. And this doesn't even take into account the tax credits, which, depending when you bought the vehicle, it may have been phased out, depending which vehicle. So this is quite an interesting exercise, and certainly for us, it was a nice touch. Now, certainly, I would not advise anyone to buy the vehicles just because you think it'll save you money. Now, if it was just a Model 3, that may be different, and the circumstance may be different in terms of how much money you need to spend on charging infrastructure or whatever else. But generally speaking, to save money to pay for these vehicles, it doesn't always work out for the Model 3 because it's much lower cost. It probably does work out better. I think for the Model X, it's not so much the case. That's a quite expensive vehicle, but the two combined together, you can see how it's quite a compelling story. And so, I wanted to, close on the series, this 7-part series I created in terms of how I use the Tesla APIs to, in conjunction with Google Sheets and the Google application script, to build out these different tools and calculations. It's kind of a hobby. It's kind of fun. And in some of these cases, you really have to be careful. They're not, what I would call production quality. So they could fail sometimes. So if you really need it to charge, I suggest you probably take more precautionary steps to your charging habits because some of these things don't run all the time. It's infrequent, but it happens, so you don't want to be caught by surprise. And I think as more features come out, it'll be more exciting through the APIs. I think there'll be more information that comes out. You can get more functions. For example, I think all that whole section I spent on calculating the start times and then scheduling the charge times, I think a lot of that would be fixed by simply them opening up the API that I can set the charge time in the vehicle. If I can do that, then I don't need to run a trigger. I don't have to worry about the car waking up. That's a lot of headache, and I think it would make this sort of exercise much more reliable. And I think that's probably a pretty simple thing for a Tesla to do, and I expect over time it probably will be available. And so, if you think about new ideas, new ways to use this information, I've seen some other ones out there in terms of like locking doors and unlocking doors based on geolocation. Certainly let me know. I'd be happy to look into that or answer any questions around that. And to maybe collaborate and build some projects, that'd be cool as well. But certainly, if if you're interested in more videos, or if you want to request specific API or calculations, I'd be happy to look into those and maybe make more videos. And certainly leave me a comment and or hit the like button and subscribe. And certainly that's a good indication that this is interesting to you as it is to me, and I'd be glad to share more. So thank you for listening in on one or more of these different series on what I did to leverage the Tesla API. Thank you.